The following program is part of Cable in the Classroom, a free service of the cable telecommunications industry and your local cable company.
Hello again, Reese Davis here in our ESPN studios. We're proud to present SportsFigures commercial-free. It's where science meets sports. Today, New Jersey Nets All-Star Kenyon Martin has our Greg Abbey plotting graphs using NBA stats.
That's good. Good. Oh, thank you. Kenyon! Bring it in, buddy.
Yeah, Coach.
All righty. Okay, I got the stats, all right, from the last 10 games. Okay, let's see. We scored, let's see, the first quarter of every game, we, let's see, well, we got 12 points against the Suns. That's okay, all right. Listen, why don't you hold this for a second, and I'm just gonna make this, put the first quarter here, all right, and then sold out of those. Good. Okay. And there are the fourth quarter stats. Okay. So, what does this tell us?
I don't know.
Yeah, me neither.
Let's go watch Sports Center.
All right, cool.
SportsFigures. Put your brain in the game.
If you were coaching a basketball team, you'd want to figure out your team's strengths and weaknesses. Now, there's tons and tons of information on all these stat sheets, but how the heck do you organize them?
We want to make a picture of the team's performance. So how do we do that? Let's start here with a scoreboard. It's basically got two things on it. Points, obviously, and time. Because NBA basketball games are measured in time. 4 12-minute quarters. 48 minutes.
Points and time. Now, if we can make a picture of these, we can figure out where in the game your team had momentum and where it went flat. And then we can compare that to which players were on the floor during that period to figure out which combination of players worked best together. You could also use it to look at the other team's performance and figure out how to beat them. So, I'd say this is pretty important stuff. In math, a number that can change is called a variable. Now, the number of points is going to change, and the time is going to change. To show the relationship between any two variables, all you got to do is make a line graph. We see graphs all the time, right? In newspapers and magazines, on TV. They use them because graphs give us a quick, clear picture of variables that we can interpret at a glance. And as the saying goes, a picture is worth 1,000 words. Okay, so how can we graph points and time? Well, to help us take a look at it, we've got Kenyon Martin of the New Jersey Nets. Now, Kenyon graduated from the University of Cincinnati in the year 2000 with a degree in criminal justice. He also swept the Player of the Year awards that year. Was also the first pick in the NBA draft by the New Jersey Nets. Now, this is his third season in the league, and last year he helped lead the Nets to the NBA Finals, leading the team in both blocks and points. So Kenyon's going to take a little time to help us make some points with graphs. Okay, Kenyon, we want to make a graph of a game that compares how two teams were scoring over time.
To graph something, you make a horizontal x-axis and a vertical y-axis. Each axis is going to be one of our variables. We've got time and points, so we'll make our x-axis time and our y-axis points.
Okay, but does it matter which we put on the X and which on the Y?
Well, the time of the game isn't something we control, so we call that an independent variable. That goes on the x-axis.
The independent variable is the one you know before you do the experiment, and the points depend on what we do.
Right. That's called a dependent variable. And dependent variables go on the y-axis.
Right.
Points depend on what he does.
If you wanted to graph a game minute by minute, we'll scale our x-axis 0 through 48 minutes.
Okay, what about the Y-axis points? What scale do we use?
Most games are never going to go over 130 points.
Check.
So we can make our y-axis 130 points and be pretty safe our numbers will stay on the graph. Almost.
Okay, guys, so we've drawn our graph and labeled our variables, points and time.
For the minutes on the x-axis, each line represents 2 minutes. For the points on the y-axis, each line represents 4 points.
Okay, now what?
You need data to fill the graph.
Data. Okay, what's data?
The information you're graphing, the numbers, that's called data.
You need to score minute by minute for the game.
What we really need is statistics, and basketball teams have plenty of those. So let's go to Basketball Hall of Famer and ESPN commentator Bill Walton and the SportsFigures blackboard to get our data.
When you hear us call a game, you'll hear plenty of statistics. We get them from the folks at the tables you see courtside. They keep track of everything that happens, play by play, second by second. Basketball games move so fast, so how do they keep up? I'm here with my main statistician, Rusty. Rusty, how does it all work? You guys keep everything together, but what do you actually do here?
I keep track of shots, what kind of shots, fast break points, turnovers, points off turnovers. We have it all, Bill.
How many fouls on Allen Houston, though?
He's got 3 fouls right now.
Okay, so when the game's over, you have the story of the game in numbers. For the SportsFigures blackboard, I'm Bill Walton.
Okay, you guys, I got the 4-1-1 right here, all right? So how are we going to do this? How are we going to compare the teams?
Well, we're going to plot the total points, the score, minute by minute for each team throughout the game.
Plot. What do you mean plot?
That's what it's called when you put points on a graph, plotting.
For each minute on the x-axis, we're going to plot the total points the Nets have scored on the y-axis.
Then we do the same thing for the Nuggets. If we use a different color for each team, it'll be easy to compare performance.
Okay, cool. Let's plot the Nets points with the yellow sticker. Let's see. Okay, minute 1, 0 points.
All right, well, hey, we'll start down here on 0 on the origin, and we'll go count over 1 on the x-axis and count 0 on the y.
All right, cool. Let's see. Minute 2, 0 points. And we're off to a shaky start. Minute 3, Kid explodes with 2 from downtown. Kittles dunks for 8 points. Minute 4, it's Kittles again for 2. Minute 5, Kid fast break for 2. Minute 6, Kid again for 2. Minute 7, Jefferson from 21 feet for 2. Minute 8, Kid from 25 for 3. Minute 9, Martin with the hook shot and Jefferson dunks for 4. Minute 10, Martin from 22 feet for 2. Minute 11, the big 0. Minute 12, Williams with the layup and Martin from downtown at the buzzer for 5 points. Woo! What a quarter. Okay, just come on in. All right, second quarter. Come on, let's go. Minute 14, get back in there. Minute 14, Harris from 21 feet for 2. Minute 48, Rogers draws a foul. First free throw, good. Second free throw, good. At the buzzer, it's the Nets with 99 points. Whoa, what a game, huh? What a game that was.
So who won?
Oh, well, we don't know yet. Now we got to plot the Nuggets points. We'll use pink for them. All right, get back in there. Oh, Hilario with the slam dunk and only 16 seconds left. Too little, too late. The Nets take it 99-79. Good night, ladies and gentlemen. Okay, so now we have our graph. Check it out. Once you've plotted all your points on a graph, you have to connect them with a line. That's why we call it a line graph. The line is what lets you see the picture of the graph. We'll use different colors for each team.
When we talk about a line on a graph, we talk about its slope. Now, the slope of a line is its rise over run. How much it rises or falls, how steep it is over a distance. It's the slope of a line that carries information.
So what's the slope of the line telling us here?
How steep the slope of the line is at any point means a lot of points are scored.
Right. So like right here, for instance, from minute 16 to 26, we got a very steep slope, so we obviously scored a lot of points. We were hot. So I'm going to figure out which players are on the court and which plays we used.
Well, when the slope of the line is horizontal, that means no points were scored.
Right. Like here, from minute 28 to 32, we didn't score a single basket. So I definitely want to know who was on the court then.
Over here is the final score of the game, where x equals 48.
You can draw a line from 0 to the final score for each team and find out their average points per minute.
Okay, cool. Let's try that.
One of the great things you can do with a graph like this is to connect your beginning point and ending point to find an average slope of the line. On this graph, it gives us an average of the overall points scored per minute. The steeper the slope of the line, the higher the points per minute scored. See, it doesn't matter who had hot streaks, or if one team scored more points early or late in the game, the team with the higher points per minute average wins the game.
So I see you're in pretty good shape. So it's lifting weights and running and sprints and all of that?
All of the above.
Right. So you would tell kids that's what they should work on, I guess?
Yeah, you can run, lift weights, but you don't want to start lifting weights too early.
Right,
You
right.
want to wait till your body's developed.
Now, what about, you see a lot of guys slamming dunks, and on SportsCenter they're always putting on the dunks and stuff. So is that the stuff? What should kids work on when they're in school coming up?
The fundamentals.
Right.
You know, all the dunking and stuff will come. You know, you need to work on your ball handling and your shooting and free throws. You know, that's the most important part of the game. You know, the things that people overlook.
Right.
Martin knocks it down from the side.
So, Kenyon, what are some other graphs that we can make that might be useful in looking at a team's performance?
You just graph the points per minute for the game, but the points per quarter would be good. That way you can look at the floor of the game.
Okay, so the variables for that would be quarters and points.
Right. The x-axis would be the quarters, and the y-axis points.
Okay, so how do we graph points by quarter?
To see that, it'd be easiest to use a bar graph instead of a line graph like the one we just made.
Okay, and how does that work?
Instead of plotting points and connecting them with a line, you draw bars that represent the totals.
You can have bars side by side of different colors for each team per quarter.
Okay, that all sounds good. Let's try it. Bar graphs use bars like this to show numbers on the axes. For the first quarter, the Nets scored 30 points. So we draw a bar in the first quarter that extends up to 30. The Nuggets only scored 15 points, so we make a bar to 15. Bar graphs are best for comparing several things over the same variable. See, the quarters are all the same size. What we're comparing are the two teams' performances during the quarter. Look, we can see at a glance that the Nets dominated in the first 3 quarters. So, Kenyon, it looks like you guys were really kicking some butt here in the first 3 quarters, but fell off a little bit here in the fourth. What happened?
Well, once you're up by a certain amount of points, or you're losing by a certain amount of points,
right.
You know, coach get the other guys like they don't get a lot of playing time and opportunity, you know, to get in and showcase their talent.
So a graph will tell us a story, but sometimes we have to interpret what it's telling us, right?
Exactly.
All right. How would we plot a line on this graph for average scoring over all 4 quarters?
Well, first you have to find out the average per quarter.
Then you take the total number of points scored and you divide it by 4.
Okay, well, the Nets scored 99 points, so what would that be, Mary? 99 divided by 4 is?
24.75 points per quarter.
Okay, how would we graph that?
You draw a flat line across at 24.75 on the y-axis.
And what about the Nuggets? How about their points?
Well, their total was 79.
Okay.
So that's an average of 79 divided by 4
is
19.75 points per quarter.
Nice work. All right, let's put those lines on our graph, all right? Okay, so what can we see from our graph now?
Well, the total number of points per quarter is sometimes above the average and sometimes below.
Right. Well, that's what average means, right? It gives us an overall look at the numbers instead of the ups and downs. If we look at our graph, we can see that the Nets were above average for the first 3 quarters and below average for the 4th quarter, and that the Nuggets were below average for the first 3 quarters and above average for the 4th quarter.
Take a look at each team's average. They're not that much different.
Yeah, but if a team scores 5 points more per quarter, it could win the game by 20 points, which is what the Nets did. If we were to take the area under our average line like this, that's going to equal the total points the Nets scored. See, the area under the average line for each quarter is 24.75 points. Add up the 4 quarters and you have the 99 points the Nets scored. That might seem obvious and simple when your average line is straight like this, but it gets more complicated if you have a graphed line with a curved slope. Finding the slopes and areas under the average line is what calculus is all about. But we don't have time to get into calculus right now. No. So, Kenyon, what other kind of graphs might be helpful?
You can make graphs for individual players to see where they're strong or weaker, or graphs for certain combination of players. You can graph anything.
Anything?
Whatever you want.
Really?
It's up to you.
Right. Anything numbers can say, graphs can make a picture of. Here's something else to think about with graphs. By changing the scale of the graph, you can affect the way the graph looks and the impact it has. Okay, Kenyon, so here's the slope of the net scoring performance from last night's game. What do you think?
Okay, not bad.
Not bad. All right, well, what about this one?
It's not such a good game.
Well, actually, Kenyon, it's the same game. And all we did was change the y-axis point scale from 100 to 200. You see, you got to be careful with graphs. Even though the appearance is that the team didn't play as well, it's actually the same game.
Oh, so you have to look at the scale of the graph to be sure.
Exactly. Okay, so what did we learn?
The graphs make a picture of numbers so you can compare 2 variables, like points and time.
You make a graph by creating an X and Y axis. Each axis is for one variable.
You scale your axis according to what the variables are. Weight, time, points, temperature, whatever.
If you have a variable that can't be controlled, like the time of a game, that's called an independent variable, and it goes on the x-axis.
If you can control it, like points scored, then that's a dependent variable, and that goes on the y-axis.
The numbers on a graph are called data. When you put them on a graph, it's called plotting.
The line is defined by slope, the rise over run, and you can make a line that's the average slope on a graph.
And different types of graphs are better to compare different types of variables.
This coaching stuff is complicated.
Here, Greg, I made a graph of our one-on-one game.
Oh, cool.
The red is me and
Okay.
the yellow is you.
Oh,
Down
okay.
here.
So what does that say about my game exactly?
But you have to get a game first, then we can work on it.
So that's it. I'd like to thank Kenyon Martin and the New Jersey Nets, and of course our students, Dave, Evan, Stacy, and Mary, for helping us out today on ESPN Sports Figures, the hoop variable.
Distance. Anything that's moving has kinetic energy, and energy can be transferred, like from your hand to the wood.
You can find out how much kinetic energy by using the formula KE equals 1/2 the mass times velocity squared.
We measure kinetic energy in joules.
Even though your bones can withstand the blow, you still have to know what you're doing.
Well, that's it. We'd like to thank everyone that helped us out today. Tiger Schulman, Ron Schulman, our students, Christina, Alex, and Stephanie, Tyrone, Joseph, and Dennis on ESPN Sports Figures, Breaking Energy. Yeah! Ha! Why didn't I think of that in the first place?
We'd like to thank today's athletes for donating their time to help put your brain in the game. I'm Reese Davis, and we'll see you next time on Sports Figures.
ESPN Sports Figures is presented commercial-free for educators to tape and use in the classroom.
For a free teacher's curriculum, to order the Sports Figures series, or if you have questions or comments,
Visit our website at espnsportsfigures.com.
you can also call 1-800-565-0452.
This has been a presentation of ESPN, the worldwide leader in sports. For more, log on to espn.com.
Sports Figures. Put your brain in the game.
The preceding program is part of Cable in the Classroom, a free service of the cable telecommunications industry and your local cable company.